This video is on solving radical equations, part 3, and it will focus on applications that involve radical equations. So we are on problem 9 in our note packet, and in this problem it says, find the exact length of the unknown side of the right triangle. So in chapter 6, previously, we learned about, or we reviewed, the Pythagorean theorem. And just to remind ourselves, it only works for a right triangle. So we have to know it's right, which they tell us, and we know because it has a little box right here. And we know that the Pythagorean theorem is a squared plus b squared equals c squared. So that's how we know to use that formula, because we have a right triangle and we don't know what one of the side lengths is. So just to review, the length that we plug in for c is the longest side. And the longest side is always the side that is opposite of the right angle. So that's how we know this is c. So this has to be c. This one could be a or it could be b. It's up to you. So a squared plus b squared equals c squared. And then we're going to go ahead and plug in our values. And then we're going to go ahead and simplify. So 6 squared is 36. 8 to the second power is 64. And then we can combine our like terms. And then lastly here, to figure out what c is, if we just think about it, what number squared gets us 100? So if you think about the answer to that, it would be 10. So if I want to undo a square, so in problems numbers 1 through 8 in videos 1 and 2, you learned that a radical with an index, so if this radical doesn't have a little number there, we know it's 2. So when these two are the same, they undo each other. So whatever I do to one side, I have to do to the other side. Now when I put this square root into a problem, you're going to learn in the next chapter that you need to put plus or minus whenever you enter into the problem a radical that wasn't already there. However, because the reason being is 10 squared is 100 and negative 10 squared is also 100. But being that in this particular problem, we're talking about the side lengths of a triangle, and the side lengths of a triangle have to be positive, that is why right now we're not going to need to put the plus or minus. So our answer is just 10. So we'll talk again more about why the plus or minus in future chapters that have no real life context would need the plus or minus. So the unknown side of the triangle is 10 feet. So this side would be 10 feet. Okay, so if we look at example 10, so again we have a right triangle. The side that is opposite must be C. I'm going to have this be A and this be B. It does not matter which one is which. So we have A squared plus B squared equals C squared. So our C value, we're going to enter 15. The A or the B, it doesn't matter, is 5. We're going to go ahead and simplify. 5 squared is 25. 15 squared is 225. And we want to solve for B, so we want to, because there's an exponent higher than 1, normally what we did was we would do minus 225. And we would have b squared minus 200 equals 0, and we would try to factor this. So that's one way to solve an equation where the highest exponent is 2, is to set it equal to 0 and factor. However, now that we've learned about radicals, now instead, if we can get this by itself, which we could, so if we subtract 25 to both sides, if we get the variable and the exponent by itself like this, instead of factoring, we now officially if we're able to get the exponent and the variable alone like this and just a number on this side, then we could get rid of the exponent by square rooting both sides. Since this is a 2, it's going to be a square root. And then this goes away, so we're just left with b. Again, normally we would write plus or minus, but because b is the side of a triangle, which can't be negative, that is why we don't need to put the plus or minus on this problem. So now it says in the directions, find the exact length. So the exact length is the square root of 200. However, we know that we are always supposed to simplify our radicals from now on. So instead of leaving your answer as the square root of 200, we want to leave your answers completely simplified. So you are going to use the knowledge you gained in section 8.3 on simplifying radicals, and go ahead and simplify this. So I'm going to go ahead and simplify it to the square root of 100 times 2, because I know that 100 is on our perfect square list, and it goes into 200. So I'm using method 1. And then the square root of 100 is 10, and then the square root of 2 cannot be simplified because none of these numbers go into 2. Now, if the problem asked us to write it as a decimal, which it doesn't, we would enter that into our calculator, and it's about 14.14 feet. So it didn't ask in the directions to write it as a decimal, but I would to make sure it makes sense. So if this is 14.14 feet, you want to make sure that it is not bigger than this, because the C value, the length across from the right angle, should be the largest. So if you had left your answer as 200, that would make no sense. So this side should always be the longest, so that's how you can catch a mistake. Alright, so another example of when we could use radicals is in a problem like number 11. It says a baseball diamond is a square. So I'm going to draw a baseball diamond. Okay, so I'm going to have this be home base, first base, second base, and third base. And it says the distance between consecutive bases is 90 feet. So that just means from here to here, that's 90, here to here. They're all 90. They space them all the same, 90 feet apart, all the way around. It says, how far does a catcher, so the catcher plays at home base, how far does a catcher throw the ball to get from home plate to second base? So if a catcher throws the ball all the way across here, it wants to know how far that is. So it doesn't say use the Pythagorean theorem, but we know we would use it because if we think about this shape right here, because they tell us we know it's a baseball diamond is also a square, this is a right angle, we know that we have a right triangle, and we know that this is 90 feet and 90 feet, and we don't know what this side is here, and here's that right angle. So that's how we would have to draw a picture and think about what we're doing is the Pythagorean theorem. So a squared plus b squared equals c squared. And we know what we're trying to find is c because it's across from the 90-degree angle. (90) squared is 8,100. And then 8,100 plus 8,100 is 16,200. And then instead of setting it equal to 0 and factoring, since we have the variable and the exponent alone, we can square root both sides. And when we put that symbol into a problem, we need the plus or minus. But because we're talking about a distance, we know that it's not plus or minus, because a negative and a positive squared can both give this value, but in the context of this problem, we're not going to include this. Now it says, round your answer, if necessary, to a whole number. So we're going to go ahead and put this in our calculator. Square root of 16,200. And then if we look at our answer, it's a decimal. It wants a whole number. So a whole number means no decimal. So what that means is I need to take the 127.279, right? We got all of these values after the decimal, and we only want a whole number. So we have to look at the number right after the decimal, the tenths place, and if this is 5 or higher, we round this up because it just wants a whole number. So we would say that C is about 127 feet. So if we were answering this question, it says, how far does a catcher have to throw the ball to get from home plate to the second base? So I would say that the catcher has to throw about 127 feet to go from home base to second base.